Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the lecture 5 of digital signal processing. I am Muhammad Atif and my registration number is 16D108. Today I will tell you about the basic operations. So in this lecture I will explain shifting, reflection, scaling and impulse response. First of all, starting from the shifting. In shifting, it shifts the signal either towards right or left. Suppose we have an example x of n equal to minus 1 0 and 1, and we have 0 index at 0, and the system y of n equal to x into n minus 3. This basically shifts the signal towards right 3 times. This is the input x of n and this represents the y put y of n, and I put n minus 3 equal to 0 and n equal to 3, and then I add 3 to the indexes and it shifts the signal towards right 3 times. In this signal I have amplitude of minus 1 at minus 1, and in this I have amplitude of minus 1 at 2, 0 at 3 and 4 at 1. 1 at 4. Similarly, if it is n into x plus 3, then it shifts the signal towards left 3 times, n plus 1 equal to 0 and n equal to minus 3. Now the second operation is reflection. Reflection is similar to flipping, which I explained in the previous lecture. And this we multiply the index with -1. I have an example x of n equal to minus 2 1 2, and I have 0 index at 0. This system represents the input x of n and this system represents the output y of n, which is x into minus n, and this is the replica of that input signal. This is basically the mirror of the input signal x of n. Now the third operation, which is scaling. In scaling we have two types: amplitude scaling and index scaling. In amplitude scaling it increases the amplitude by number we multiply x of n. For example, if I have x of n equal to minus 3 1 and 2, then it increases the amplitude by 4 times due to this number, so the output will become minus 12 4 and 12. And in index scaling, the index scaling compresses or expands the input signal, as compression and expansion is explained in the previous lecture. As y of n equal to x2, and it compresses the input signal, and y of n equal to x into n over 2, and it expands the input signals by 2 times. Now the last topic of the today lecture is impulse response. Impulse response of the system is that response in which we fed the system with impulse, or the system is fed with impulse. This delta n is impulse and is fed with and the system is fed with impulse response, and this h of n represents the impulse response of the system. As we know that delta n is 1 at 0 and 0 else. In impulse response there are two kinds of response. First one is finite response and second one is infinite response. Finite response of the system doesn't depend upon the previous value. It doesn't depend on previous value. Suppose we have an system in which signal in which x of n equal to 1 0 1 and minus 2, in which I have 0 index at 1, and the system y of n equal to x of n into x and minus 1, and I have to find the response of this system. So h of n equal to delta n minus 1 if this pass through the system. So similarly I take different indexes h of n minus 1. At h of n minus 1 I have delta minus 1, and this equal to 0 because delta of 0 equal to 1, and otherwise at all value it is 0. So at h of 0 it is 1 because of del of 0, and h of 1 it is minus 1 because of del of 0, and h of 2 it is 0. So the final response of the system is 1 0, at which 0 index is at 1, and this is the finite response. Now move toward the infinite response. In infinite response it depends upon the previous value of system. Suppose I have system y of n equal to 0.5 y n minus 1 and plus x of n. H of n impulse response will become 0.5 h n minus 1 plus delta n. If no condition, if there is no condition, then there's an important condition which we take h of minus 1 equal to 0. At h of 0 we have 1 because of del of 0, and h of 1 we have 0.5, this becomes 0 and this is 1, as this depends upon the previous value of the system. So h of n equal to 1 0.5 0.25 up to so on, and this is known as the infinite response of the system. That is it for today. Thank you.